Welcome back. We're still in lesson 3. We've been talking about factoring and the use of the zero product property. In the last video, we saw how to use the zero product property as an inverse to a quadratic equation. In fact, we solved an equation using that property. In this video, we're going to solve the same equation from video 8 in this lesson, but this time we're going to do it graphically. Let's take a look at a problem. We're going to start by reading the entire problem statement slowly. Problem 6, complete all 5 steps of the graphical technique to solve the equation x squared equals negative 2x. We begin our work on this problem after we've read it by asking ourselves the question, is there an equals sign? We see an equal sign right in the middle. We know immediately that means we're going to solve this equation. What type of equation is it? Cuadro. Square. So this is a quadratic equation. When solving equations, we have 2 techniques to work with. In this case, we're actually specifically told we want to use a graphical technique. Remember that to solve an algebraic equation using a graphical technique, we complete 5 steps. Step 1 was to identify and graph the function on the left-hand side of the equal sign. Step 2 is to identify the function on the right-hand side of the equal sign and graph this function on the same axis as in step 1. Let's start with these 2 steps in our actual problem. We're back at our problem. Here we see that the left-hand side of our equal sign is x squared. In this case, we're going to set y1 equal to x squared. On the other side of the equal sign, the side that we'll call the right-hand side of the equal sign, we have the function negative 2x. In this case, we'll set y2 equal to negative 2x. Let's go ahead and see how to fill out the entire table at once. Notice my calculator has data from a previous problem. In order to get rid of that data, I just go to the y equals, I push clear on the previous function and clear again. In this case, I want an x squared, so I hit the appropriate button in y1. y2, I want a negative. Remember that the negative is the small sign at the bottom, 2 times x. I'm going to want to go to my table, but I know that I'm going to want to set my table first. In particular, I'm going to set my table with the start value negative 4, and my delta between rows is 1. That's exactly what I have here. My independent variable is going to be automatically calculated. Let's go to the table here. I can now fill out the values of the output for both my y1 and my y2. I'll start with y1. At x equal negative 4, I get an output of 16, which makes sense because negative 4 squared is negative 4 times negative 4, which is positive 4 times 4, which is 16. Negative 3 times negative 3 is 9. That's exactly what this says there. 4, 1, 0, 1, 4, 9, 16. Those are the outputs. Over here, my negative 2x. At negative 4, I get a positive 8, which makes sense because negative 2 times negative 4, negative times a negative is a positive. 2 times 4 is 8. Negative 2 times negative 3, that's a positive 6, which is exactly what my calculator says. 4, we can notice the pattern 8, 6, 4, 2, 0, negative 2, negative 4, negative 6, negative 8. Looks like each time I move down a row, I'm moving down negative 2. And that is because the slope of this function is negative 2 over 1. In each of these rows, I'll write the ordered pairs. Let me go ahead and fast forward that so you don't have to suffer through the entire thing. Now I've got my entire set of input-output pairs. I'm going to give a quick call out. Remember, the input in each case is determined by the x. In this case, negative 4 for y1 produces the output 16. In ordered pair form, negative 4 comma 16 is that input-output pair for y1 at that input. For y2, we see the output is 8. In other words, negative 4 produces the output 8 for this function. So we write the input-output pair as negative 4 is the input, 8 is the output. Once we have all this information, we can go ahead and graph Once again, I'm going to do that in fast forward mode so that you can get the gist without having to sit through all the pain. Two things to notice. This graph doesn't actually give me the value of 16, so I kind of made my best possible guess. Real parabolas have curves. Fake parabolas are called absolute values. So I make sure to interpolate, connect the dots using curves. Kind of see a smiley face sitting there. I'm going to go ahead and highlight in blue since this is my y1 function. I probably should also label this as y1 equal to x squared. We move on to graphing y2. I'm going to do that in fast forward. I highlight and I also label this as negative 2x. We go back and review the graphical technique. We've already identified and graphed the left-hand side. We've also identified and graphed the right-hand side. The next two steps of my graphical techniques are to find the points of intersection between the graphs. Where do they touch? Then we're going to write each point of intersection as an ordered pair and specifically identify the first coordinate of each ordered pair. Notice we've got 2 points of intersection. There's 1 and there's 2. We'll say that the left POI, point of intersection, happens at the point, let's see, x is negative 2, y is 4. In other words, the first coordinate is negative 2 on that one. Similarly, the right point of intersection happens at x equals 0, and then it looks like y is equal to 0 as well. The first coordinate in this situation is 0. We remind ourselves that we could have seen this same information from the table. The input negative 2 produces the output 4 in y1 and the output 4 in y2. In other words, the point negative 2 comma 4 is on both graphs. Similarly, the input 0 produces the same output on both graphs. This point 0 comma 0 is indeed on the blue and the red. We've now finished steps 3 and 4 of the graphical technique. The last step is to set the variable from the equation equal to the first coordinate of each point of intersection. Recall that we're going to put our final solution in the form variable equals value. In this case, we finish this up by writing our solution x equal to the first coordinate negative 2 or x equal to 0. Every time we should check our work. However, because we've already solved this, we know that these are solutions. We saw that in the last video. Notice we've solved this problem in 2 different ways. One was the zero product property, one was a graphical technique. Both techniques produced the same solution. Let's dive deeper into our use of the zero product property to solve quadratic equations.